I'm Michael Flagg. I apologize for not having a name tag today. I'm pretty sure it evaporated yesterday. So why is a QC program critical? What's the meaning of life? What are we doing here? These are important questions, and hopefully at the end of this presentation we'll answer all of them. So I'm going to go, this is a brief overview of what we're going to talk about, basically understanding very basic concepts of quality control. I'm going to go into the data validation templates a bit, and then EPA's, how we interpret and use those templates, and how they relate to our requirements, some available resources, and there's a slight bent to ozone. This is an artist's rendition of the actual ozone particles going into, into the inlet here. So we can't talk about quality control unless we talk about the quality system. This is a kind of a diagram that I've used in other presentations, but basically it illustrates kind of the collection of things that create the quality system that allow us to collect high quality data that are kind of memorialized in QAPs and QMPs, and they include things like data quality objectives, measurement uncertainty, quality assurance, and of course quality control, which is what we're going to focus on here. Typically, quality control, when we talk about ambient air monitoring, is related to 1-point QC checks for gaseous instruments, which are the zero-span precision checks that we do. They're required bi-weekly, but most of people do them weekly or nightly, which is great. For PM, flow verifications, co-location, and then also I kind of consider calibrations to be a QC measure as well. All of these things together, really are the foundational core of how we collect the data. And specifically, QC checks EPA defines QC checks as critical in quantifying measurement uncertainty. Measurement uncertainty directly affects data quality, and it really affects EPA's ability to use data that you've collected in EPA's regulatory decision making. We define measurement uncertainty as precision and bias, and we are all trying to accomplish essentially precise, unbiased data is the main goal here, to get as true to the truth as possible. So the CFR, the Federal Code of Regulations, for gaseous instruments prescribes the calculations that are required for precision and bias that are performed on an annual basis. And these are done using the results of the 1-point QC checks, which are always calculated as a % difference. The requirement is in the table here. For ozone, for example, it's the coefficient of variation of 7% and the bias, absolute bias of 7%. Historically, this has been calculated on an annual basis. The note here that has been subject of much heated debate and conversation has been a shift in interpretation on how we consider 1-point QC checks in our data validation process. So the new, I'm quoting, new interpretation from OEQPS in order to implement this on a national level is essentially to say that the % difference for each check, so each nightly check that you do, must be below the annual precision and bias criteria. It must be below 7%. That is the way that OEQPS has interpreted the regulation, and it is a slight shift from what we've dealt with in the past. So this is something that you should all be paying attention to, and hopefully will become a little bit clearer as we go forward. Which brings us to the data validation templates. The data validation templates are where EPA puts a succinct table of all of the requirements for each pollutant, ranging from critical, operational, and systematic criteria. How many people have seen the validation templates or keep them with you in the field? Okay, that's good. Everyone should have these templates available to you. They are an extremely valuable tool. They detail all the requirements for each pollutant, and even more specifically for PM instruments. So there's a PM filter-based validation template, there's a continuous validation template, et cetera. But the main gist of the thing is that each table for each pollutant has critical, operational, and systematic criteria. And generally, the way we look at these things is that as you go from systematic to operational, there's a greater increasing risk of data invalidation, meaning that if you miss critical criteria, the likelihood of you losing data or data being invalidated is high. This is the example for ozone. And this is the language in the templates that kind of talks about how we interpret what the critical criteria mean. And it states, observations that do not meet every criteria should be invalidated, unless there are compelling reasons and justification for not doing so. For ozone, OMG, guys and gals, guess what? Critical criteria for ozone are the 1-point QC checks. They are your precision point, they're your 0 point, and they're your span point. And all of these points, the precision point has to be within 7%. Another slight note quickly is that in this new kind of era or interpretation, EPA has provided some clarity around what is a passing check. So we've added a 7.1 to the criteria to indicate that you can't have a 7.3 and round down to 7 and say you've got a passing check. It must be below 7.0 or be at 7.0 to be a passing check. So how do we interpret these things? Basically, if they're not met, the data is invalid, which seems kind of cut and dry, but that's the way that things are being interpreted. Unless, as I mentioned before in the previous slide, there is compelling evidence to keep the data, and we'll talk about that in a minute. A simple recommendation, don't exceed the criteria. 7% is attainable, and the easiest way to avoid complicated, compelling evidence demonstrations is to stay within these limits. So how do we stay within these limits? We recommend that you have implementation of warning or action limits that are below the critical criteria limit, so you're catching problems before they rise to the critical criteria level. 5% is just an example. I know some agencies use 3%. Mainly keeping a close eye on the data, and this is done well by folks who increase the frequency of your zero span precision checks. They're only required by regulation to be performed every 2 weeks, but most folks do them nightly, which is what we recommend, is that you do them every day, and that you're reviewing the data every day. If you're not reviewing the data every day, you're going to see things like instrument drift. This is actual precision data from an instrument in California, and you can see that over time, the results of the precision checks do drift. So keeping an eye on this data is extremely important for the validity and the quality of the data collected. So I mentioned compelling evidence. So what do we do when a criteria is not met? The interpretation of what compelling evidence means is that you must show the analyzer was operating correctly or appropriately, and that the failure of the criteria was due to other factors. This is a very simple schematic of an ozone site with the analyzer and essentially the calibration system. So what's happening here with compelling evidence is really showing that the cause of your precision check being above 7%, like an 8%, has to do with a failure in your calibration system. So, were there leaks in the sample line? Was there overpressurization? Other examples could be issues with the calibrator. Is your zero error good? These are things that you should take a look at in determining whether or not there was an analyzer failure or whether or not the check was failing because of an issue with the calibration system. So this often can include bringing an independent transfer standard in, doing a check with a separate instrument to check the system again. If this passes, that maybe give you indication that your transfer standard at the site is not operating appropriately, or it's even challenging the calibration system itself. What is happening in the field, and how are you determining whether or not the issue is with the calibration system or with the analyzer? And the one thing that I'll point out here that's not on the slide that is really important to the compelling evidence component is documentation. So if you fail a check and you go through this exercise of determining whether or not it was analyzer failure or a calibration system failure, document what you're doing. It's extremely important because when we come on TSAs or when data is reviewed closely or challenged, we're going to have to go back and recreate what was happening on each of these different instances. So again, This is a part of the new process that accompanies the new OAQPS interpretation on how to handle data in AQS that fails the 1-point QC check criteria. So if you run a 1-point precision check and it's within the acceptance criteria, everything's great. Report the check to AQS in your QA transaction, and the routine data is valid. If it's not within the acceptance criteria, we go back to this determination of analyzer failure. If there is an analyzer failure, then the QC check is a valid check, but the ambient data should be invalidated, meaning that there was something wrong with the analyzer and the data that collected during that time period is outside of our criteria. If it's not an analyzer failure and it's something like with the calibration system, then the QC check is considered invalid and should be submitted to AQS via the QA transaction with a null code of the QC check. So the QC check will not actually be reported to AQS. It'll be nulled out when we calculate our annual statistics. And in this case, the ambient data is considered valid because it's not an analyzer issue. So that's the critical criteria, compelling evidence. There's 2 other operational and systematic criteria that we're going to talk about really quickly. They're both very important. They have a little bit different of interpretation. So operational criteria may be cause for invalidation unless other quality control information demonstrates otherwise. And then systematic criteria usually do not impact the validity of the data immediately. What I will say about these 2 things is that EPA generally has a weight of evidence approach to data quality. So if things are happening, if there's numerous components of these operational criteria that may be considered invalid for a certain purpose, we look at the data in a holistic way and we try to analyze the issues with the data collectively to come up with an overall solution. So just to say that they're not critical, their operation and systematic criteria, doesn't mean that they're not important. They are very important to data quality. So in summary, QC checks are the foundation of understanding data quality, which are the critical criteria in most cases for a lot of the pollutants and the validation templates. Agencies should implement procedures to account for instrument drift before we reach these critical levels because we don't want to invalidate data where we don't need to. A note on the new AQS flagging process, and don't forget that operational and systematic criteria are also super important. Just because they're not critical does not mean they're not important. And I'm going to pass to Mallory, and then we'll take questions afterward together. Right? Okay.
Okay. Are we turned on?
Sorry.
It's okay.
Maybe there.
How's that? All right. Hello, everyone. Mallory, and we're going to continue on with the topic of 1-point QC checks. There will be a little bit of repetition, especially in the area of where Michael was talking about critical criteria, but that'll just serve to emphasize the importance of those aspects of the 1-point QC checks. All right, so I'm going to focus more on the district level, talk about some details and some of the procedures that we do. Overall, I'm going to limit this to just ozone-only sites, and then we'll talk about the regulation and frequency, the ozone level acceptance criteria. I have an example of a QC check with a timeline, and then we'll go into valid versus invalid checks. I have a couple examples for AQS reporting, and I'll finish off with a discussion on decimals. All right, on regulation and frequency, we got the EPA regulation here. As Michael mentioned, just to repeat again though, a 1-point QC check must be performed at least once every 2 weeks. And more frequent checking is strongly encouraged. And why more frequently? Well, it'll minimize data loss. when something does go wrong, and it will go wrong, we'll be able to bracket the data, and we'll have a shorter interval for bracketing the data. So in the end, it should result in less data loss. Frequent checks also give the operators the ability to better track the operation of their monitor, particularly with drift. You know, if you're doing QC checks more often, you can see the drift on your monitors and keep track of them as it's getting a little bit wide. My agency runs our QC checks every other day, and we have everything automated, and really there's just little downside once you have everything automated. As Michael was saying, some people are running them every day, but again, it works well, and when everything is working well, you know, it really contributes to better AQS statistics. This is just a shot of a AQS one-point quality control report. So we're conducting checks every other day, so we get about 180 checks per year, right? The minimum is every 2 weeks, 26 checks per year. So I just highlighted in red, you know, we got 100% for all of our gases, and anybody that's doing them just a little bit more frequently shouldn't have trouble getting that. On the ozone assessment value, again, the regulation states that the value should be between 5 and 80 parts per billion. We use an assessment value of 50 to 55 parts per billion. That's just a concentration that we routinely see during the day. So you know, we're trying to do our check in the range of a concentration that we frequently see. The acceptance criteria is either plus or minus 1.5 ppb, or plus or minus 7%. I didn't go into the 7.1%, but Michael explained that pretty well. For the range we're using, 50 to 55, we're going to use 7%. The 1.5 parts per billion is going to be more for trace gases when you get down at lower levels. And then we also use the action level of 5%. You know, we want a buffer. We don't want to just come in and find out that our QC check was above 7%, because if it happened overnight, you've already lost some data. So we want a buffer in place, and when the percent difference gets above 5%, we go out, or at least we schedule, you know, a visit to that monitor. I have a QC check example. First, a question. How many out there, when they're conducting their QC checks, lose 2 hours of data? And for an ozone-only site, does anybody lose 2 hours? No hands. That's excellent. How about 1 hour? There's just a few hands. Come on, wake up, you guys. Got lunch coming up pretty soon. I know most of you. Okay, all right, let's try this. How many are losing or not invalidating any hours for a 1-point QC check? Okay, good. There are a few. That's where I'm going with this. So I'm going to show you an example of, this is our best case example for one of our sites, and we run our 1-point QC check. We only run the 1-point QC check. We do the span on other days for ozone, and we don't have to invalidate any hours. So in order to make all this work, again, it's for ozone only, and your equipment, you know, has to stabilize pretty quickly, right? The timing is critical, and we steal a few minutes. We steal minutes from 2 consecutive hours. And when all this works, again, it contributes to pretty good data completeness. Rather than go through all the details, I'm just saving this for archival purposes. I'm going to go right into the graph. So this is a 1-minute graph of our 1-point QC check. And we begin our check. This is for one of our sites, Thousand Oaks, and it's a tight site. It works well. Everything works well here. We begin the gas phase of our 1-point QC check at 46 minutes past the hour, past midnight. That's right there. And I should explain, the blue line is the actual gas phase or zero phase, and then the red line is stability. Okay, so 46 minutes past midnight, the gas phase begins. That runs about 7 minutes, and it stabilizes pretty darn quick. And then right here, it stabilizes, and you can see stability is good. And so once it stabilizes, we run that for about 7 minutes, and that phase is done. We grab a number. We grab the last 5-minute average for our number, And then immediately at about 1 a.m., not at about, at exactly 1 a.m., it goes into the 0 phase. And again, we run that for 7 minutes, and that stabilizes there. We run it for another 7 minutes, and then we pick off that data value. The whole check is done at 14 minutes past the hour. So the first hour we started at 46 after, right? That's a valid hour. And then we ran it. We ended at 14 minutes past 1. And so we got 46 minutes for that hour. So that's valid as well. So therefore, we had 24 valid hours in a day. It works pretty well. Now, for us, this is a best case scenario. We have 2 other sites with ozone only, and we do lose an hour. But if we can make it work at one site, it's my goal to make it work at the other sites. It's just we have some calibrator issues, and I'm not sure exactly all the reasons, but I know we can get it to work at all the sites. And this is what I really like about this. All right, data completeness report. This is for our Thousand Oaks site for 2018. We have 10 months out of the year where we had 100% data completeness. And the 2 months we didn't, we had 99%. So that's pretty darn good. Again, it's a tight site. It's a best case scenario, at least for us. But it's really nice to highlight this site and make it a goal for us that we can get this to work at other sites. All right, so your 1-point QC check has occurred overnight. Operator comes in next morning, and then first thing she or he will look at will be the calibration report. And if the percent difference is under 7%, things are OK. Data is all valid. However, we really want it under 5% because that's our action level. So if it's under 5%, and I should state the 1-minute graph is stable, then no action is required. We can go on with our other duties. If it's greater than 5%, then that analyzer requires action. And so we want, you don't have to run out there right away, but we want the operator to schedule a visit to that site pretty quick, because we don't want to get to 7% and then invalidate data. However, in the morning, if you do come in and the difference in your 1-point QC check is greater than 7%, then that's a critical visit, and that's immediately that day. We want you out there because you're already going to have to invalidate data. There's no question about it. We're invalidating data. And this is just a copy of our daily calibration report. This is what our operator looks at in the morning. I just highlighted our Thousand Oaks site, and it just shows that it's a tight site, 51.1 for the expected or the assessment value. I know we use those terms interchangeably. 51.2 for what we call the actual or the monitor value, just a 0.12 difference. All right, I have a couple examples on AQS reporting of the 1-point QC checks, a valid example and invalid example. So this is just a screenshot of the top of an EPA memo. It's a great memo, very detailed. It's got some good examples in it. And this memo is dated January 30th, 2018. It supersedes another memo that came out in 2017. And so be sure you use the latest memo. There's just one small change in it, which I'll get into in the next slide. And then at the bottom of the slide is just the web address for it. All right, so this is an example, one example of others that could be for an invalid QC check as far as AQS reporting goes. So let's say you have a calibration system failure, and you know that your test concentration gas is not accurate. All right, in this case, we're looking for the compelling evidence that the data is valid. On the right, I have a picture of our T700 calibrator, and there's a regulator pressure warning message. In this case, we had an obvious zero-error system failure. So that would be at least one part of the compelling evidence. When this happens with a QC check, the important thing is that you want to report this check to AQS with a 1C null code. Now, going back to that memo, in this memo, 130, there's a memo dated in 2017, and it says IC. And that is incorrect. And so they just issued this update to make it 1C. Apparently, the IC code was already being used. So make sure you use the 1C null code. And what that does is it tells AQS that the QC check has occurred for your data completeness. Now, I didn't ask, but I would like to ask, is anybody doing manual QC checks? There's one. Yeah, there's a few. Okay. Yeah, there's a handful. And is anyone doing QC checks? This one I expect hands. So everybody wake up a little bit. Is anyone doing QC checks more frequently than once every 2 weeks? All right, one more question. Just keep going. Is there anybody only doing a QC check once every 2 weeks? All right, and that's good. So this shouldn't be too big of a deal, right? But if you are not doing quite as many QC checks, then you need that 1C code just to get credit for it. That's the main point here. All right, now this is an example of a valid QC check. And in this case, for this example, the calibration system was OK, and we knew the test concentration gas is accurate. All right, but the QC check exceeded criteria. So the picture on the right just shows a photo of a T400 ozone box, and it has a sample flow warning message. In this case, we had just had a pump failure, right? So this analyzer needs repair, and we know we're going to be invalidating some routine data. We're going to, and in this memo, again, they give you some examples of null codes to use, but the key point is use a null code, right? Because you're invalidating data there. In this case, the QC check is reported to AQS. According to the memo, though, it is not used for precision and bias statistics. All right, and I'm going to finish up with a discussion on decimals. So in our 1-point QC check reports, previously, we were just reporting in whole numbers, parts per billion, for our 1-point QC check. And by using whole numbers or just 0 decimals, it creates a report. Well, it can create a report with a little variation. So our Thousand Oaks site, again, I already showed you that's a pretty tight site. And we were getting many, many consecutive QC reports with either 0 or 1.9%. In fact, we had a run of over 50 QC checks. It was just 0. So the checks were accurate, and they were within EPA regulations. They were fine. You just had to look into the details. But to somebody from the outside, I get it. You're just doing a quick scan of reports. And if I were to see 3 months or so of 1-point QC reports with 0, yeah, I'd want to look into it a little bit more. So, but again, I'm emphasizing they were OK. They were valid QC checks, and the data was accurate. But because of that, we thought, well, why don't we add a decimal point? So we did. And it did require a little bit of extra staff time. We had some report issues, and we had some logger issues. We had to also schedule it. You can't just flip a switch and all of a sudden go to collecting 1 decimal in your whole network. But we did all that, and it works pretty good. I have a couple copies here of the raw monitor assessment report. The one on the left was with no decimals, so before, and of course I picked a section that was all 0s because that was the actual report. And then after with decimals, you can see highlighted in red, still it's a good site, but there is some variation there. And after all, the QA handbook does recommend keeping more decimals than the minimum, so we're doing that. All right, just closing. Just a summary again of these critical criteria for 1-point QC checks, and this one specific to ozone. Do your checks a minimum of every 14 days. Looks like everybody here is doing that. More frequent checks will benefit you. The percent difference has got to be less than 7%, and we use an operational level of 5%, but you want an operational level something below 7% just to give you a buffer there. And the ozone range has got to be between 5 and 80 parts per billion. We use a level that's typical to a daily concentration, and that's recommended. And that's it. And I guess we have time for questions. Go ahead, Don.
It's a two-part question, and I want both the EPA and district viewpoint on it because they may be different. In a situation of the ozone check, precision check, is the ozone data only in jeopardy if it fails? Is it in jeopardy if the check is never performed? And then going to the other side of it, does the district or agency have the option to select which checks they report if they do more than the minimum?
Do you want to take the first part? I'll take the second part.
Sure, yeah. So if the check fails and the procedure outlined by the guidance suggests to invalidate that data, if the check isn't performed, what they've done now with AQS functionality is that AQS is going to be tracking how the interval at which QC checks are performed. And so it will flag those data. But at this point, it's kind of a gray area, I guess, is my response, in the sense that if you don't have precision checks, you can't assess the validity of the data because you don't understand the precision of the instrument at a given point in time. So it's not an automatic invalid, but it does come into, we would consider it in our weight of evidence analysis, like how much confidence can we have in the data if we don't understand the precision, is something that we consider.
And then on the checks, we don't pick and choose our checks. We report them all. Actually, it's probably a Michael question again if the district has the option, but we don't exercise an option if we have it.
Yeah, you should report. I mean, you should be reporting all your checks. What we're trying to avoid is cherry picking of, hey, exactly. I performed a check. It was at 6%, but I performed one right afterwards, and it was 5%. You know, so we want to avoid that kind of, you know, cherry picking of the data in that way. So we encourage everyone, just as a measure of transparency, to submit all the data for all your checks.
I have two questions. Question number one is, when you submit, like in the case of Mallory, he said they do a precision check every other day. You have agencies that do it like us. We do 6 precision checks a week. And you have agencies that do once every 2 weeks. Now, the annual assessment, that could be a little bit misleading because you could, if you do it every other day, you could have 100%. But you may be missing lots of checks and still get credit, full credit. So how does that?
Yeah, I mean, the frequency of the checks definitely influences the annual statistics. But, you know, the statistics are calculated on an annual basis with all the available information. So, you know, that variability is kind of just, it's going to be inherently different for checks that are performed once every 2 weeks or with a more statistically robust data set of a check every single day.
Yeah, but AQS does not distinguish between an agency that has...
No, it doesn't, yeah.
Okay. My second question is, I get asked all the time, why is the audit criteria different than the 1-point precision?
That's a great question. The powers that be, whoever they may be, I don't have an answer for you on why EPA has chosen wider criteria for the audit than the 1-point QC check. Other than my own personal thought on it is that, you know, you're doing checks every day. You're keeping the instrument in line as best you can with your 1-point QC checks, with your 0-year spans, and you're keeping a close eye on that. The audit is a check on the system that occurs once a year. And so, you know, you can think of it as like expanding, you know, like shells of protection against data invalidation, right? I mean, it's a check on the data once a year in terms of comparability throughout the entire network, rather than a comparison at site to site for an instrument-specific measurement.
If you also noticed, audits are not considered critical criteria. So critical criteria is a hard yes or no, and I believe with audits, you have more flexibility to look at other QC information to determine whether data are valid or invalid. And I believe it on your chart it was systematic.
Yeah, I mean, you're looking at, with the audits, you're looking at that, like how the instrument performs in comparison to other instruments in the network. So, I mean, inherently, that's going to be a little bit more flexible than, you know, your instrument-specific check, which you want to be very, very tight on. It's just a different purpose, really, is my thought on it.
Hey,
Well, sorry. Go for it. And then after this, everyone that has a question, we have a Q&A panel just up, so you can ask your question of them.
okay, so yeah, my question is, maybe I'm just getting tangled up in the vocabulary, the wording of things, but you know, in the data, in the QA manual, they talk about your span, and the criteria is like 7%, and they talk about the QC check in the criteria is 7%. And then they talk about the zero drift. And I guess the drift is what I don't understand, because it seems for the span and the precision point, it's obvious. You compare your response to the true concentration, and it needs to be within 7%. But then they throw the word drift at you with the zero. So does that mean my zero from the previous day's zero can only differ by 3%, or is it needs to be within 3 parts per billion of zero? And then, you know, it also what also kind of adds to the confusion is that the criteria changes depending on your frequency of checks, which sort of implies that there is this like time lag component to it. Do you have, again, maybe I'm just sort of reading too much into the wording there.
No, I mean, words are important. They mean certain things. We should be careful about what we say about these different checks. I don't know off the top of my head, but we can take that back and look into it. Why they chose drift over rather. Yeah. Right.
Just keep plus and zero and don't worry about it. That hasn't been a problem, but.
All right. Thank you, Michael and Mallory.